Okay, basically you guys have a little outline in front of you. It just kind of goes over the important things that I think that I'd want to show you guys about the switchgear, right? Number one is its functionality. Now the functionality of the switchgear basically can be two things. And number one is the auto normal function, normal state that it's going to be in. And that basically, there's a switch on the other gear on MV13 over there that's in the first compartment on it over here that has a hand auto and manual switch. And the normal state for this gear is in the auto position, right? So in auto, the timeline over here, or the actual outline, shows you the position of all the switches. When it starts in that position, you have basically all your mains, both mains are closed. You got MSV13 main is closed, and MSV13 tie is open over there, right? So it's open, the tie is open on that side. Manual switches, which are these right here, these control the transformers. Okay, you got to kind of stay behind that, but let me see from over here. These are manual switches that control the transformers on both sides of the building. So there's 4 of these total. And you can see the name tags here call out the transformer name tag, right? So this controls TX21 on that side of the building. And these are manual, and these are always in the closed position. You know, unless an emergency state or something, then you would manually open them, right? They remain in the closed position at all times. And that's what it shows you on that little outline right there. The position for these in a normal state is always closed. So you got the 2 on each side, and then the other manual switch right here would be the generator. This is the manual switch that leads to the generator right here. And it's labeled from standby generator, and it has the same application. So it's just a manual switch that's in a closed position at all times, right? So in the normal process, which is in auto, the functionality is all based on the sequence of operations that was submitted, that was given to us in the specifications. That sequence of operations is page 2 of what you have here. And basically, I don't think we need to go through every line item on it, but what it does is it states what's going to happen in all different scenarios. Okay, you have 2 parallel power feeds coming from RP4 that one goes to one side and one goes to the other side of your building over here. Now, if one should go, that's what the first loss of voltage on MSV13. If one side should go, it will transfer over and pick up power automatically from MSV14, which is this switchgear. Okay? And vice versa. So if this one goes down, if there's a problem with power on this side, automatically it'll switch over and pick up power from the other side. So that's your first line of defense here if you have power trouble. Second would be total loss, and that's what it explains down here a little bit further on the last section over here. You lose both, right? You have a 60-second delay from the loss of voltage. This gear sends a start signal to the generator. The generator then sends a ready to accept load back to MSV14, which is right here. Then the generator will open the main switches. So the main here and the main there will open, okay, on both sides. You have it confirms that the switch is open, so it even sends a signal, hey, we're open now. So it's a separate signal that it sends over to make sure that it's open, right? Because we don't want to parallel power feeds into each other, or cross power into each other. It'd be bad with medium voltage. So then it sends the close signal to the generator breaker, and you're on generated power. So now you're running on generated power, and then it'll back out of that. Anytime that that power is received on your normal, let's say it's Edison power, your supply voltage at RP4, it'll start the sequence to back out, and it will start to initiate the shutdown for the generator. The breaker over here will now open. The mains will close again, and you're back on normal power, and this will continue to go down on its shutdown process. All right? So basically, that's the functionality per this sequence of operations for the normal operation of the switchgear. So that's what it should be in at all times, you know, and it shouldn't take much from any of you guys. You really should never really be touching this unless you're into the section function, or the second function, which would be in manual. Now manual is only going to happen, and if you go back to your front timeline here, it's only going to happen when you're in a testing or repair state, right? No other time will you be in manual. If you're either doing maintenance on something down the line, or you guys are testing something, or something needs to be repaired, it's failing, right? So that'll be the only point, and only your authorized representatives can do this, you know? I don't know if all of you will be qualified for that. I know only one or two right now that kind of understand the complete system, and I don't, you know, and it's because I haven't met all the rest of you, so I'm not sure yet, but only IUAs, you know, personnel that they direct to touch this stuff can do it in the manual operation. And that's because you need to know the whole series down the line before you can start opening and closing switches, right? So manual operation, you would go down to MSV 13 where we had talked, and you'd flip it into manual. From that point now, you will have access to go into any of these. This is the tie switch for this gear right now, and you could flip the open close, and it would activate the actuator, which would actually open and close your gear. The main is on right here, and the main has the same function. The mains and ties at both ends have the same function. They're powered actuators that actually close and open your switches. And you just flip open and close on the top here.
Does it run from battery power?
It runs from 48 volt battery power, so it should never be interrupted. And the battery over here obviously is on trickle charge, so either the generator's going or power's on feeding it, so you'll never have interruption. 48 volts DC power. And that is for the automatic switches, which would be a main and a tie here, and a main and a tie over there. So that is the manual operation. And basically, again, to reiterate, it would be, let's say you need to do something with the generator down line, or some of the gear needs to be fixed or something, then you'd flip into manual, right? Maintenance. There isn't really that much maintenance on this thing, guys. You know, the only thing that the O&M really calls out is the cleaning of the 12 kV connections and bus. And that's just a standard deal with 12 kV or any type of high voltage. You try to keep it as clean as possible. You know, that's going to be up to you guys. It recommends certain things for maintenance in the O&Ms, which will be provided to you guys. But really, you know, after reading through there, basically you'll just have to figure out a time when you can de-energize to clean this, because inside here collects, and I'm sure you guys are all aware, if anything has a little crack hole at this facility, it gets a lot of dirt in there and a lot of dust. And this is vented from the bottom, so you open it up and it's pretty dirty in there already, so that'll be something on your end of it that you guys need to decide when would be the right time to clean it. And obviously it'll happen in a de-energized state. So the other thing on here I have on the list is a visual inspection. The things that you want to visually inspect on this gear obviously are weather. On the other side you have a sprinkler situation that needs to be addressed, where water's actually puddling under the gear. You don't want water puddling around 12 kV switchgear, so that issue will have to be addressed. Visual inspections on this, really the only real visual inspection you can is look at the weathering of the switchgear and make sure that it's not corrosive or water's getting into the gear at any point, and visually inspect the blades. Okay? Inside here, this is the only real visual inspection point that you can look into the gear. And in here you'll see the blades of all the switches. Every one has a window. And if the switches are failing at any point, you'll be able to see or tell by some arcing on the blades themselves. So I'd just say a standard visual inspection on this, would probably want to be put into your maintenance routine. So the only other thing on these switch gears that possibly could be a maintenance issue are the fuses. Every single one of them inside is fused all the way across, and I've provided spare fuses to Randy per the specification, and you have a spare fuse for everyone that's in here, and you'll know when they go out. It's going to tell you when they go out. You're going to have a leg down in your facility. So when that happens, that'll be a point when either you hire out to do it, or you guys replace the fuses yourself. And they're really easy, so it's not very difficult at all. But basically that's it. Maintenance on it is the only thing is to keep the interior clean on the O&M. So any questions you guys have, feel free. No questions? All right. That'll end our presentation.